4.4, solving exponential and logarithmic equations. Okay, so here's the deal. We are going to.
Let me fog up your glasses, David.
Those are both pictures. It doesn't matter, just pick some place.
Yeah, I was about to say.
Okay, so solving exponential and logarithmic functions. We have to talk about one-to-one properties and inverse properties. Your one-to-one property. Okay, one-to-one property looks like this. If a to the x equals a to the y, then that means that x equals y. Okay, if the bases are the same and they're set equal to each other, that means that the powers equal each other. Okay, you also have, if you have log base a of x equals log base a of y, these bases are still the same. So if the bases are the same, then that means x equals y again. Okay, that's the one-to-one property. Then there's the inverse property. Josh, you're always trying.
Because I'm trying to learn.
Then you have the inverse property, and the inverse property says if I have the base of a raised to the log base a of x, of x, then that means that it's going to equal x because this will cancel out. A raised to the base of a is going to cancel out. Okay, the base of a raised to log base of a is going to cancel out. And vice versa. If I write it as log base a of a to the x, it's also going to equal x because this is going to cancel out. It's the same thing. So because of that, we're going to simplify and solve some one-to-one and some inverse property equations. Okay.
Wait, so the first inverse equation, is that like in the power spot?
Yes.
Okay.
Yes. It's a raised to the power of log base a of x. Okay? So the base of a cancels out the power of log base a, leaving you with just x. So if I have 2 to the x equals 32, okay?
I'm just going with the inverse property.
What?
Inverse property.
We're gonna look at, we're just mixing it up right now. I know. If I have 2x to the 32, okay? What is another way that I could write this? Or how do I figure out what x is? How do you solve what x is? If I have 2 to the x equals 32. Yeah, you have to figure out what power do I raise 2 to make it 32. So what do you raise power? What power do you use to get to 32?
6.
No.
2.
It's what, Lindsay? 5, because 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So if I have 5 sets of 2, then I get 32. So I would write it.
Wait, that's always tricky, bro.
It's always tricky to you.
Yeah, because like 2 to the 5th seems like it'd be 25 to me every single time.
So here's how you can figure it out without just like knowing that off the top of your head. Okay? What you would do is you would take 32 and you would give a factor tree. 2 and 16, 2 and 8, right? 2 and 4, 2 and 2. And the reason I want to take 2 into it is because this base is 2. So it's telling me what number I want to go into there. Okay? I want to take a 2 out and I want to see how many times that comes out. Hello.
So we just do that circle thing with the circle.
Yeah, it's fine.
Oh, that is correct. I'm sorry. But I was supposed to send it down for Bree too, and I forgot to send it down. Can you send her up to come finish it? Thank you. Thanks. Bye. Okay. So you have that. which means that I have 1, 2, 3, 4, 5. So I have 2 to the x equals 2 to the 5th, which means x equals 5, because I changed it so that the bases are the same, so that I have a one-to-one property. Does that make sense? I change it so that these bases are the same, so that I have a one-to-one property and I can tell what x equals, because x equals y.
So all we have to do is just do that tree thing.
Yes, you're going to need to break it down. Okay, that's probably the quickest way to break this down. Okay, we're going to have lots of examples today.
Yes.
Let's say we have log base 4 of x, okay? And then I have minus log base 4 of 8 equals 0. Okay. How do you think I should go about solving this?
Well, if the base was say x
Maybe
equals
put 'em in the
y.
fraction.
Okay, Dakota's on to something. The bases are the same, right? I have log base 4, I have log base 4.
Since log base 4 of x equals.
What
It
I
should be a fraction.
Okay, look. Over here, I have to have the log and the log set equal to each other, yes? So what do you think I'm going to do with this
Make
negative
them
log?
equal each other.
Yes, I'm going to add this to both sides.
I'm a genius, dude.
Find me all the way to Phoenix. Cause I'm a genius.
Okay, so now I have log base 4 of x equals log base 4 of 8. So what does x equal?
Somebody's pushing their face against the door.
X equals 8. X equals 8, okay? Bree, I have another one attached on here. Just give it to Mrs. Ferguson. Okay. So log base 4 of x equals log base 4 of 8 means x equals 8 because the bases are the same and they can cancel. Okay? And my x equals my y. So you might have to rearrange the equation. What happens if I have natural log of x minus natural log of 6 equals 0? What do I do?
They have to equal each other.
They have to equal each other, so I need to
So
add
add ln 6
Yep.
plus ln 6.
So I get natural log of x equals natural log of 6. Do they have the same base? Yes, because a natural log has a base of what? Of e, which that we missed on our quiz a little bit. Some of us didn't, when we changed that one equation with natural log, we didn't change it to e to a power. We changed it to natural log to a power. That's not how you represent it. You have to represent it with e. Okay, so I get x equals 6 in that case. Okay, let's try 1/3 to the x equals 9. Okay, what do you think I need to do with this equation?
Do it to factor it out.
Okay, so 9 factors out into 3 and 3, because I clearly want 3's, because that has a 3 in the denominator spot. Okay. So that gives me 3 squared. But the problem is 3 squared is 9. It's not 1/3, right? Okay? 3 squared is 9. It's not 1/3. So how do you change this, okay?
And then put the negative.
Flip what?
The power.
3 or more.
Nice. Which one am I flipping? 1/3 or 3? Because here's the deal. Let me explain something. If I flip 3, I get 1 over 3 squared. What's 3 squared? Well, I get 1 over 3 to the negative 2, right? Okay, which gives me 9. That's not a base of 3, correct? So I need to make sure that on this one, I flip the fraction I already have. So that I have 3 to the negative x equals 3 squared. Now, what would x equal?
Negative.
Yeah, x is going to equal negative 2, because if I say negative x equals 2, I have to divide by that negative 1, and x is going to equal negative 2. So when there is a fraction, you're going to have a negative exponent at some point.
I'm a little bit confused.
Okay, Dakota. Because I have a fraction, I have to have a negative exponent someplace. Okay, you break 9 down like you said, and it gives me 3 squared. The problem is, if I flip this one to say 1 over 3 to the negative 2, that gives me 9 here. Yes?
Yes.
Okay, because 3 squared is 9. This is still just 1/3. So I have to flip this one so that the bases are the same. Okay, and once I flip that, that means that this exponent becomes negative. This base and this base are the same, so they cancel. Negative x equals 2, and then I divide by that negative 1 to get what x equals. So I have to work it backwards. Okay, let's look at this one. What happens if I have ex equals 7? That one's tricky looking. I just have e to the x equals 7.
So we just do the factor it out again.
Ooh, can't factor this one.
Oh, yeah.
Okay, what does e go with?
X.
It goes with what, Lindsay? It goes with natural log, ln. Okay, so I need to change this one into this type of function, but with natural log. Okay, if I change this side, I'm going to say natural log of e to the x equals natural log of 7. Here's the deal. ln and e are the same thing, so what are they going to do?
Cancel.
Cancel, leaving me with x equals the natural log of 7. That one's tricky. When you have an e, you have to change it into natural log. What, Matthew?
And why does it matter if it's an E or if it's ln? Like, why do we have to sometimes change it to an E?
Because when you're doing graphing, you can't use ln, the natural log. You have to use the base of e for that. And e represents the number. It's like a special number in math, like pi is a special number in math. So when I'm needing numbers, I have to use e. But when I'm doing logarithmic functions, I have to use ln because that's how you solve logarithmic functions. So it just depends. If you're coming up with a number answer, you need e. If I need to figure out what x equals in this case, I have to switch it so that I can cancel it out. Okay, what happens if I have this? I told you we're just doing a lot. Natural log of x equals, boys, stop talking. Natural log of x equals negative 3. How would you change that to fix that? Natural log of x.
Do we change the natural log to an E?
Well, yes, kind of.
What?
You're going to use an inverse property so that you raise e to the natural log so that it will cancel out. Okay? So that is your clue, Matthew. Anytime it's natural log, I'm going to have to throw an e in there. Anytime it's e, I have to throw a natural log in there. So I'm going to change this so that it says e to the natural log of x equals, okay? And if I change e to the natural log of x, that means the other side has to change to e to the negative 3. What happens is, whatever these bases are right here, they become the exponents, okay? So that my base is the same. Now that my bases are the same, what does x equal? X is going to equal e to the negative 3.
So we divided.
Because right here, this is canceling on this side. Okay?
So we divide each of them by themselves.
No, I wasn't dividing. I just underlined those. I'm
Oh,
sorry.
okay.
I was saying, right now they're the base. I have to change them to the power. Okay? So natural log and when I have a base of e is probably the most confusing. What happens when I have a log base 10 of x? That is what I can use in my calculator, correct?
Correct.
Okay. What happens when I have log base 10 of x equals negative 1? How do I change that so that I can solve?
Well, you would do a log or switch it so it would be 10.
Yes. I would switch it using this inverse property. So whatever my base is becomes my large base so that it cancels. I get 10 log base 10 of x equals okay, equals 10, because that's the base I'm using, to the negative 1. This cancels, yes, on this side, giving me x equals, okay, what does 10 to the negative 1 turn into? Not negative, just 1 over 10. Okay, so it transfers to 1 over 10 so that I don't have a negative exponent. Okay, so we're using these properties to change everything around. Last one of this section, and then we'll move on to something else.
I use the restroom.
Yes. What happens if I have log base 3 of x equals 4? How do I rearrange that to solve?
D3 log,
Uh-huh. 3 log base 3 of x equals what?
4.
Yes, Lindsay, 3 to the 4th. This becomes my power. This becomes my power. This now cancels, giving me x equals 3 to the 4th. Well, what is 3 to the 4th? It's what? 81. Yeah, 3 times 3 is 9. 9 times 9 is 81. Yep. And that's how I get my answer. So on some of them, well, on all of them except for when I'm dealing with natural log and e, I get an actual number answer. Okay? That's one-to-one properties and inverse properties. That's all that is. Let's talk about solving some exponential equations. We're going to do I think we're going to do 2 or 3 of these and then we'll be done for today. Let's say you have e to the x power equals 72. Okay? E to the x power equals 72. How would I go about solving that? I gotta get rid of e, remember that.
So natural log.
Natural log, good. So natural log is what goes with e. So I have natural log of e to the x equals natural log of 72.
And use the inverse.
So it'll be
X
x equals
equals
natural log of 72.
Yes, x equals natural log of 72. And since it said solve, what do you think I need to do from there?
Plug it in.
Plug it in. So I'm going to press natural log 72 on my calculator, and I should get that x is congruent to 4.28, yeah, when I round it. Something around there. Yours will be close. 4.28 something. Okay. So that is what you're looking at for right now. What happens if I have an equation like this? 3 times 2 to the x equals 42. What do I need to do before I even, or how do I go about solving this? What do I need to do?
Would you divide 3 both sides?
Yes, divide 3 by both sides. Because I want to get whatever this power is by itself. So then I get 2 to the x equals, what's 42 divided by 3? What did you say? 14? Yes, 14. Okay, now I have 14 like that. So I have 2 to the x equals 14. Here's the problem. If I do the factor tree on 14, I get 2 and 7, right? So I don't have all 2's. So I don't have anything I can do base-wise. So what do I have to change this to solve it then? Make it a what? I can't just divide by 2 because this is a power. Yes, I need to make it into a log of base 2.
Is it just like the e thing?
It's like this one right here. I need
So
to
if the
change this.
factoring doesn't factor out.
Then you have to use log. Yes. Then I need to use log with the same base. So I'm going to say log base 2 of 2 to the x, right, equals log base 2 of 14, right? Now, this makes that cancel, correct?
X equals log 2 base.
Okay, now, we're not done yet. We have to add another step to this. Because it said evaluate, how can I change this so that I can evaluate it? We did it on your quiz yesterday. It was called using the change of base formula. So what's the change of base formula? Tell me I need to do.
X equals natural log 14 over x over, natural log 2.
Yeah, you can do natural log or regular log, it doesn't matter. But whichever number is larger goes on top, and whatever number is smaller goes on bottom. You guys, some of you switched that on your quiz.
I did.
Okay. So now I just plug into my calculator log 14 divided by log 2, and you're going to get an answer that is congruent to 3.81. Okay? So when it says evaluate, I need you to take it all the way to a number answer.
Okay,
Okay? Let's do let's do 2 more, and then we'll solve. We'll leave factoring for tomorrow.
That's cool.
Let's try 4e. 4 to the e. I think that's what it's written like. Oh no, 4 times e. 4 times e to the 2x. Okay. And then minus 3 equals 2. How am I going to go about solving this? Add 3. Good. We're just going to use basic algebra skills. So I get 4e to the 2x equals 5. Now what?
You divide.
Yeah, divide by 4.
Almost at 5.
And I get e to the 2x equals 5/4. Now what?
Do what we did last time.
Which is,
Take the natural.
yep, use natural log. Natural log, is that right? Natural log of e to the 2x, right? Equals natural log of 5/4. So this cancels, yes?
So then the x equals ln.
Oh, not x, 2x.
Oh.
2x equals natural log of 5/4. How do you get rid of the 2?
Divide it.
You divide it, or I multiply by a half. Doesn't matter which one you do, okay? If I divide it in your calculator, make sure that you put parentheses, you're going to press natural log, parentheses, 5/4, divided by parentheses 2, like that, okay? And then you're going to tell me what you get because it wants a number answer.
Holy cow.
And x should be congruent to 0.11. Okay? That's solving that. We're going to do one more, and then I will give you homework. And tomorrow, there are a lot of examples in this book. Let's say we have this. 2 times 3 to the 2t minus 5 up top equals, minus 4 equals 11. Okay. How do I start to solve this? Yep, add 4. Add 4, add 4. I get 2 times 3 to the 2t minus 5 equals 15. Now what? Divide by 2. 3 to the 2t minus 5 equals 15 over 2. Now what? Yes, take log 3. So log base 3 of 3 2t minus 5 equals log base 3 of 15 over 2, yeah? This cancels. So 2t minus 5 equals log base 3 of 15 over 2. Woo. Now what? Add 5. 2t equals 5 plus log base 3 of, I'm going to change this to just 7.5 so it's easier to work with. Now what? Divide by 2. T equals, and you're going to say 5 plus log base 3 of 7.5 over 2. Now, here's the problem. If you want to solve this in your calculator, because they're asking you to solve it, you have to actually do a change of base here to solve this part first, yes?
Yeah.
So I need to change this to log 7.5 over log 3, okay? So this has to say t equals 5 plus log 7.5 over log base 10, or I'm sorry, over log 3 over 2. Yes. So when you plug that in, that's going to make it trickier. What I suggest is you figure out what this is first, add 5 to it, then divide by 3 so that you don't have to worry about order of operations in your calculator. So I'm going to say log 7.5 divided by log 3. That comes out to approximately 1.83. I'm going to add 5 to it, and I'm going to divide by 2, and you should get an answer of approximately 3.42. So when it says solve, I need number answers, which means you're applying every rule that we've learned, plus one-to-one properties, plus inverse properties to actually solve these.